Now I'm going to go back to the dot structures that we did before and look at their geometries. So the first thing you do is you find your central atom. The geometry is always based on the central atom, and you look at how many electron groups there are around it. Remember, an electron group is either a lone pair or a bond. And the bond could be double or triple or single, doesn't matter. Okay, so on this oxygen, our central atom, we have 1, 2, 3, 4 electron groups. So I'm just going to kind of keep track over here. Electron groups, we have 4. So when you have 4 electron groups, the electron geometry, that's when you have your little tetrahedron, and the 4 corners of the tetrahedron are pointing out at the corners there. Let's see, so tetrahedral is our shape. Okay, and then on this one, when we do the molecular geometry, we are only looking at the atoms. So this one has 2 lone pairs and 2 atoms. So I'm going to put an atom there, and these are my lone pairs. So the electrons are tetrahedral, but the molecular geometry is just this part with the atoms. So we call this bent, and this one is 109.5 degrees. Remember, there's a table on your PowerPoints that gives you these different names. You're going to have to memorize those names. Okay, let's do another one. Electron groups. This nitrogen, again, has 4 electron groups. And so its geometry, so wait, let's do this. Electron groups, there are 4. The electron geometry, again, will be tetrahedral. So this is like the little tetrahedron, and it has 1 lone pair. I usually draw it up, it doesn't matter, but it's easier to see the shapes if you draw it a certain way. And this has atoms on 3 of the places. There's our central atom. So this is a triangular base with the central atom kind of raised up. So the molecular geometry, looking just at the atoms, is called trigonal pyramidal. Let's do another one. This one is different because really you can have a geometry around each carbon. On those that we are looking at that have 2 carbons, we're going to make it so that they're both the same geometry. So I'll just choose a carbon. Let's look at this one. It has 2 electron groups. The electron geometry is linear. Those 2 groups are on opposite sides. And then the molecular geometry is also linear. So for this one, we're looking at, what's wrong? We're looking at just these atoms. And they're all in a straight row. Let's do one more, well, maybe 2 more. Okay, so for this one, our ozone, how many electron groups? And with resonance structures, they have to have the same geometry. So just choose one of them, and we'll count groups. This one has 3 electron groups. 2 are bonds, and 1 is a lone pair. So there are 3 electron groups. So the electron geometry Well, this one, when you have 3 electron groups, you have the central atom, and then you have electrons going out in a triangle, but it's flat. So this is trigonal planar. The molecular geometry, now we have a lone pair on one, but the other two there are atoms. And so when we look at the molecular geometry, we're only looking at the atoms, so we call this shape bent. And when it's based on the triangle, it's 120 degrees. Again, what we're talking about 120, we're talking about this angle here. Let's do one more. Again, when you have resonance structures, you can just choose one to see the geometry. So I'm going to choose this one. This nitrogen has 3 electron groups. The electron geometry, like the last one, I have a central atom and then I have 3 groups. So the furthest that those groups can get away from each other, since they repel, is to be at the corners of a triangle. So the electron geometry is called trigonal, but it's flat, so this is planar. And the molecular geometry, well, we have an atom in all 3 places, so these are the same. So now that you've seen this a little bit more, maybe you can see something I said on the PowerPoint is that with no lone pairs, these are the same. In other words, these geometries of the molecular and electron are the same if there aren't any lone pairs. Oh, I think we should do this one. It's not very interesting, but we might as well show it. For carbon dioxide, it has 2 electron groups. The electron geometry, they're just opposite each other, so it's linear. And the molecular geometry is linear as well.